谁在最需要的时候轻轻拍着我肩膀？谁在最快乐的时候愿意和我分享？日子那么长，我在你身旁，见证你成长，让我感到充满力量。谁能忘记过去一路走来陪你受的伤？谁能预料未来茫茫漫长，你在何方？笑容在脸上，和你一样大声唱，为自己鼓掌。我和你一样的坚强。
Good morning, teacher. Today I will present the Chapter 8, Mathematical Modeling. What is mathematical modeling? A mathematical model is a mathematical relation that describes the real-world situation. For example, the formula I equals PRT is a relation between simple interest and the other three quantities, that is, the principal, the interest rate, and the time. We then solve the mathematical problem and interpret its solution in terms of the real-world problem. A mathematical model is a representation of a system or scenario that is used to gain qualitative and or quantitative understanding of some real-world problems and to predict future behavior. Why study this chapter? Because mathematical modeling is used in various disciplines in the real world. Engineers use mathematical modeling to analyze the traffic flow on a line. Telecommunication companies use mathematical modeling to determine the charges for the calls that consumers make. Scientists also use mathematical modeling to predict the trends in population growth and the spread of infection diseases to ensure the well-being of human race. There are a few important components in mathematical modeling. Number 1. Identifying and defining the problem. Number 2. Making assumptions and identifying the variables. Number 3. Applying mathematics to solve problems. Number 4. Verifying and interpreting solutions in the context of the problem. Number 5. Refining the mathematical model. Number 6. Reporting the findings. Real-world problem. Identifying and defining the problems. Making assumptions and identifying the variables. Applying mathematics to solve problems. Verifying and interpreting solutions in the context of the problem. Refining the mathematical model. Reporting the findings. Repeat as needed. Real-world problem. The grocery store, which is far from your house, sells a pack of 10 kg rice at a lower price than the one closest to your house. Identifying and defining the problems. The price of a pack of 10 kg rice and the cost of petrol. Determine the distance from the two stores to your house repetitively. Find the information needed from the internet. For example, the price of a package of 10 kg rice from each store, the distance of each store from your house, the current petrol price, the car petrol consumption rate, and so on. Making assumptions. The route between the house, store A and store B is a perfect straight line. Driving car to the store. Purchasing the same number and brand of rice at store A and store B. Identifying the variables. S equals the distance between store A and store B. P1 equals the price of a package of 10 kg rice at store A. P2 equals the price of a package of 10 kg rice at store B. M equals the petrol consumption rate of the car in km per liter. N equals the number of packs of 10 kg rice to be purchasing. H equals the current petrol price in Rm per liter. S equals the differences in price in Rm for purchasing the pack of 10 kg rice at store B as compared to store A. T equals the differences in the cost of petrol in Rm for driving to store B as compared to store A. Applying mathematics to solve problems. The price of a package of 10 kg rice. Store A. Rm 25 ringgit 95 cents. Store B. Rm 23 ringgit 99 cents. Let the quantity of 10 kg rice to be purchased be 2 packs. The price to be paid. Store A. 2 times Rm 25 ringgit 95 cents equal Rm 51 ringgit 19 cents. Store B. 2 times Rm 23 ringgit 99 cents equal Rm 47 ringgit 98 cents. Therefore, by purchasing the rice at store B, one can save Rm 51 ringgit 19 cents minus Rm 47 ringgit 98 cents equal Rm 3 ringgit 92 cents. Let the distance between store A and store B be 6 km. The petrol consumption rate of a car be approximately 17.6 km per liter. The current petrol price be Rm 2 ringgit 8 cents per liter. Therefore, we save Rm 3 ringgit 92 cents minus Rm 1 ringgit 42 cents equal Rm 2 ringgit 50 cents by purchasing 2 packs of 10 kg rice at store B. Verifying and interpreting solution in the context of the problem. The resulting mathematical model is as follows. S equals P1 minus P2 times N T equals Sm times H times 2. If S bigger than T, then it is sensible to drive to store B to purchase rice and save more money. If S smaller than T, then we should not drive to store B to purchase rice. Example of using the model. S equals P1 minus P2 times n equal 25.95 minus 23.99 times 2 equal Rm 3 ringgit 92 cents. T equal S over M times H times 2 equal 6 over 17.6 times 2.08 times 2 equal Rm 1 ringgit 42 cents. Size S bigger than T. You save more money by purchasing rice at store B. Hence, it is sensible to drive to store B. Thus, the mathematical model is able to solve the problem. From the constructor mathematical model, further exploration can be made. Number 1. If all the variables remain the same, how far can store B be located so that it is an optimal choice? P1 minus P2 times n bigger than S over M times H times 2. 25.95 minus 23.99 times 2 bigger than S over 17.6 times 2.08 times 2. X smaller than 16.6 km. This means that if the distance between the two stores is less than 16.6 km, then it is sensible to drive to store B to purchase rice. Number 2. What is the maximum price of a patch of 10 kg rice at store B that will attract a person drive to store B to purchase it? P1 minus P2 times n bigger than S over M times H times 2. 25.95 minus P2 times 2 bigger than 6 over 17.6 times 2.08 times 2. P2 smaller than Rm 25 ringgit 24 cents. This means that if the price of a pack of 10 kg rice at store B is less than Rm 25 ringgit 24 cents, then it is worth the trip. Therefore, the above mathematical model allows us to not only answer the question of it is worth it for the given situation, but also allows us to determine other factors that support or oppose the decision to drive further to purchase the rice. Refining the mathematical model. The assumption made regarding the route between the house, store A and store B is straight line needs to be revised. If the route between the three places is not a straight line, how does this impact our model? If new assumptions are being made, then the model needs to be revised to reflect this change. Reporting the findings. Use symbols and diagrams when necessary to report the findings. The symbols and diagrams will depict the whole modeling process until it reaches to result. Every model has strengths and weaknesses. For example, the value of a person's time is not considered in this model. It is when driving an extra 12 km for someone to save Rm 2 ringgit 50 cents. According to this model, saving 5 cents is considered worldwide. The model did not account for any environmental consideration. It is environmentally responsible to drive an extra 12 km just to save Rm2.50. This model did not account for environmental efforts such as efforts to reduce carbon emissions. We have now seen how the mathematical modeling process works by one example as shown above. We should emphasize that we cannot use this example as a template to solve other problems. In solving problems through mathematical modeling, every individual or every group has different ideas, skills, and perceptions. Open-ended questions such as this may even generate completely different mathematical models which are valid yet result in different answers. Example 1. Jeremy saved Rm4,000 ringgit at Bank Bunga Raya with a simple interest rate of 1.5 per annum. Jeremy wants to buy a computer worth Rm4,455 ringgit with his savings. How long does Jeremy need to save? Identify and define the problem. Determine the assumptions that need to be made and identify the variables in solve the problem. In this problem, we know the principal and the interest rate. The interest from the saving is the amount that Jeremy needs besides the Rm4,000 ringgit to buy the computer. We need to determine how long Jeremy needs to keep his savings in the bank. Assumptions. We need to assume that the interest rate does not change during the period of our interest calculation. Otherwise, the formula I equal PRT will not be applied. We also need to assume that the price of the computer does not change when Jeremy has raising the required amount of money. The variables involved are I for interest, P for principal, R for interest rate, and T for time in years. This is mathematical modeling process. First, start identifying and defining the problems, making assumptions and identifying the variables, applying mathematics to solve problems, verifying and interpreting solutions in the context of the problem. Need to refine the mathematical model, reporting the findings. That's all my presentation. Thank you.
谁在最需要的时候轻轻拍着我肩膀？谁在最快乐的时候愿意和我分享？日子那么长，我在你身旁，见证你成长，让我感到充满力量。谁能忘记过去一路走来陪你受的伤？谁能预料未来茫茫漫长，你在何方？笑容在脸上， 和你一样大声唱，为自己鼓掌。我和你一样的坚强，一样的全力以赴追逐我的梦想。哪怕会受伤，哪怕有风浪，风雨之后才会有蜜源芬芳。我和你一样的善良，一样为需要的人打造一个天堂。歌声是翅膀，长出了希望，所有的付出只因爱的力量，和你一样。谁能忘记过去一路走来陪你受的伤？谁能预料未来茫茫漫长你在何方？笑容在脸上，和你一样大声唱，为自己鼓掌。我和你一样的坚强，一样的全力以赴追逐我的梦想。哪怕会受伤，哪怕有风浪，风雨之后才会有蜜源芬芳。我和你一样的善良，一样为需要的人打造一个天堂。歌声是翅膀，长出了希望，所有的付出只因爱的力量。我们都一样的坚强，一样的青春焕发金黄色的光芒。哪怕会受伤，哪怕有风浪，风雨之后才会有彩色阳光。我们都一样的善良，一样为需要的人打造一个天堂。歌声是翅膀，长出了希望，所有的付出只因爱的力量，和你一样。我们都一样。谁在最需要的时候轻轻拍着我肩膀？谁在最快乐的时候愿意和我分享？日子那么长，我在你身旁，见证你成长，永远为你